So what's true about horizontal tangent lines again? What do we know about any horizontal tangent line? What's true about them? Any tangent lines horizontal? Roman? Slope's always going to be 0, yeah. So if they're asking us to find where that is, if the slope is 0, the derivative should be 0, right? So we find the derivative and set it equal to 0, right? So now we have a vertical tangent line. Vertical tangent line's opposite, right? It's perpendicular to vertical or to horizontal. What's the slope of that guy there? What's the slope of something like this? Of a, that one's going to be undefined, yeah. Because this guy here, right? Slope is rise over run, right? So if it's diagonal like that, you go up and over, right? Count up how many you went up, how many you went over, right? So something like that is all run. There's no rise. It doesn't go up or down, right? So that top number is always 0. So if the top number is always 0, slope is 0. Okay. This is the opposite. If it's vertical, it's all rise. There's no run. There's no run at all. So the top number, there's a top number, but there's no bottom number. Bottom number is 0. Right? So anytime the bottom number is 0, it's undefined. So you can kind of see the graph here. This equation is graphed here. It's kind of an oval shape. Like I said, they're not functions. They're kind of weird. Implicit are weird kind of things. You won't have to graph these because your calculator doesn't graph them. Like a regular TI 84, 83 doesn't graph these things. I think Desmos does, but we don't use Desmos in this class, so you won't have to graph them ever. You just might have to look at a graph and decide where's the vertical tangent line, where's the horizontal tangent line, things like that. Okay, so we can kind of see a vertical tangent line. Vertical tangent line there. Vertical tangent line there, right? So we can kind of see there's going to be two. One looks like it when x is 0 and when x is 2. Kind of looks like one, okay? So first thing we got to do is find the derivative, okay? So let's find the derivative of the equation they give us. So we get 8x plus 2y dy dx minus 8 plus 4 dy dx. And then the rest is just plus 0 because the derivative of 4 is 0 and the derivative of 0 is 0. So it's just equals 0. Okay. Solve for dy dx. Okay, this one's pretty straightforward. Anything without a dy dx, we're going to move to the other side using the inverse operations. Okay. So if it's positive, we're going to subtract it. If it's negative, we're going to add it. So we get 2y dy dx plus 4 dy dx equals negative 8x plus 8. Factor out a dy dx. Two y plus 4 and then last step, divide by 2y plus 4. And we get the derivative is negative 8x plus 8 over 2y plus 4. Okay, that's the derivative, right? So how do we find the tangent? How do we find where the vertical tangent lines are going to be? What are we going to do now? Because I have, this is the derivative. Derivative's there. What's my next step in terms of finding out where on the graph is it going to be? Is the vertical tangent line? Yes, at the bottom this time to 0. This one, we don't care about the top, right? Undefined means we know 0's got to be on the bottom, right? 0 on a fraction means we know the top is 0. The bottom here we know is 0. So I'm not worried about the top. I'm just worried about the bottom. I'm going to set the bottom equal to 0. Okay? Because that will tell me where it's undefined. So subtract 4 from both sides. Divide by positive 2. And you get y equals 2. Y equals 2. Okay, so we know y equals negative 2. So kind of with these blue dots here. But they want the points, right? Point means an x and a y. So how do I get the x to go with the y's? Because right now I just have a y. That's not a point, right? Exactly. Plug it in back into the original. Anywhere you see a y, plug in a negative 2. So in the original, let's see. Anywhere I see a y, I'm going to write a negative 2. Everything else stays the same. So 4x squared plus 4 minus 8x minus 8 plus 4 equals 0. It's a quadratic because the highest exponent power, the degree, is 2. Okay, so I'm going to combine some like terms. I have some like terms I can combine here. I have a positive 4, I have a positive 4, and I have a negative 8. Luckily, all of those will cancel each other out, right? 4 plus 4 minus 8, 0. Okay. So I have 4x squared minus 8x equals 0. So I'm going to get 2 answers here. I'm going to get 2 answers because it's a quadratic, right? It's a quadratic. It's the highest exponent is 2, so that means I'm going to get 2 answers. So how do I get those 2 answers? How do I solve this? There's a couple different ways to do it, but what's one way to do it? Does anyone remember what's one way to do it? How to solve this? I can't set each one equal to 0 yet. I could do that, but I have to do something before that. That's going to be my next step. You're right. I'm definitely going to do that. But before I do that, I got to do something. Sebastian? Yeah, factor, GCF, yeah. GCF first, and then set it equal to 0. Yep. So they both share 4x. I can factor out a 4x. So if I divide by x, 4x, I get x and 2. Reverse, GCF is just reverse distributive property, the opposite of distributive property. Okay, now I can set it equal, both of them equal to 0. So now I have 2 factor terms. I have a 4x and an x minus 2. Solve for x. Well, over here it's multiplication, so the opposite's going to be division. So x equals 0. Over here is a subtraction, so the opposite is addition. And there's my 2 x's. So I have 2 x values. I have 0 and positive 2. How do I do that? I have 1 y though, right? My y was, what was my y? Negative 2. My y was negative 2. So what does that mean? How do I make those into dots? Because I got to have points, right? X and a y. So how many points am I going to have? How many points is it going to have? 2, right? I'm going to have 2 points. Boom. 2 points where I'm going to have a vertical tangent line. We know x is 0, right? And we know x is 2. So there's that. What's the y going to be? -2, yeah. -2. And then the last thing you're going to do is look at the picture. Does that make sense on the picture? Do those points make sense with what we said earlier? Yeah, they do. At 0, -2, it's going to have a vertical tangent line. And at 2, -2, it's going to have a vertical tangent line. So it makes sense with our picture. So that's how we know we did it right. Okay. So anytime you see from now on, anytime you see vertical tangent line, you're going to set the bottom equal to 0. Anytime you have a horizontal, you're going to set the top equal to the derivative of the top. That means because there was a question like that on the last FRQ. It didn't say horizontal tangent. It just says where is the slope going to be 0? And it was a fraction. And a lot of you set the whole thing, and I'm like, you don't need to set the whole thing. You just need to set the top equal to 0. If it's going to be 0, if it's undefined, you set the bottom equal to 0. Okay. All right. So the last thing is 10 and 11. 10 and 11. So look at number 10. Look at this notation here. What do you think we're going to do for this notation here? Take a wild guess. What do you think that notation means? Find derivative. Second derivative. Yep, that's all it means. That's all it means. Find second derivative. Find derivative, and then find derivative again. Second derivative. Okay? That's all that notation means. Okay, let's do it. So I'm going to find the first derivative. Oops, forgot my dy dx. Okay. And then divide by 2y to get dy dx by itself. Okay, first derivative, that's the first derivative. Second derivative. So we're going to find derivative of that guy. So how am I going to find, what am I going to use to find derivative of this guy? Quotient rule. Yep, quotient rule. Okay. So second derivative. So d squared y over dx squared. That's the notation we use for second derivative. So I'm going to use quotient rule for the second derivative. So the bottom squared. And then low, d high. So the derivative of the top is just 2. Right? High, d low, the derivative of the bottom. So the derivative of the bottom is 2 dy dx. Okay. So let me clean it up a little bit. So we get 4y minus, and then over here we have, I'm going to do distributive property here and here because I have 2 on the outside. So I'm going to distribute the 2 in there. So it's going to be minus 4x plus 4 dy dx. And then down here it's 4y squared because everything in there is squared. Wait, I should still have these in parentheses, in brackets though. Okay. So when I'm finding derivative, what do I have to do? When do I know I'm done? When I'm finding derivative. Anytime I'm finding derivative of an implicit, how do I know I'm done? Mhm. Exactly. When it's dy dx equals, right? Just like right here. All right. I knew I was done with the first derivative because I isolated that and I'm done. How do I do that down here? I mean, I know I have one dy dx, right? I can isolate this guy, right? But how do you isolate it when this guy's here too, right? How do you isolate this term? There's only one of them, right? I can isolate it. There's mathematically, I can do that. It's actually not that bad. But how can I isolate this on one side when I have this as well? And do I want to isolate this guy? Because what does this mean? This means first derivative, right? That's not what I want. I want to isolate this guy here, right? So this is where there's a little bit of a trick, a little bit of a wrinkle. Anytime we see this, we're not going to use this. We know what this is equal to. What is this equal to right here? Right here, right? Well, I don't want a dy dx and a d squared y dx squared. I don't want both of them. So what I'm going to do is I'm going to substitute. I'm going to substitute dy dx with the actual derivative because they're equal. We solved that. That's the first derivative, right? So wherever I see a dy dx, I'm going to substitute in this guy right here. Okay, so what is that going to look like? It's going to look like this right here. Watch. Mm-hmm. Yep. Let's see. Yeah, you're right. Yeah, you're right. Yeah, so let me not do that. Yeah, I don't want it because then there's going to be two dy dx's, and I don't want to deal with that. No, thank you. Let's leave it the way it was before. Thank you. Yeah, I would have got something wrong. Two. So I'm going to reverse the distributive property because you're right. If I distribute that, I got to distribute the dy dx as well, and then I would have two dy dx's, and I don't want to have that unless I have to, but I don't think I have to. Okay, let me change color here. Okay, so now where I had the dy dx before, I'm not going to write dy dx. What I'm going to do is I'm going to write what it is. And we just figured that out earlier. It's right here. 2x plus 2 over 2y. Okay. Now I don't have any dy dx's. I only have a d squared y over dx squared. And it's isolated. So now all I have to do is kind of clean this up, combine like terms, anything I can do that way. Okay, so most of the work is going to be done on the inside of the brackets here, on the inside of the brackets. You see on the inside of the brackets, I have this times 2 times this, right? So this right here is really 2 over 1. And this right here is really over 1. So you're going to multiply the tops, multiply the bottoms. Okay? I see here that I have 2x plus 1s, or 2x plus 2s. So I'm not going to multiply them together. I'm just going to put squared. Okay? So let me simplify this. Four y squared on the bottom, 4y in the front. Up here, I have 2x plus 2 squared over y. Okay. Okay. 2y on the bottom, 2y. Oh, the 2y. I forgot to write 2y in here. Right there. Yep. So it should be 2y. Thank you. Guess what? The 2's will cancel out because I have a 2 coefficient and a 2 coefficient. So the 2's cancel out there to make 1's. Okay. So now I only have one term inside of the brackets. Okay. So I have 4y minus 2x plus 2 squared over y. And then on the bottom, I have 4y squared. Okay. So again, you go as far as you need to. Okay. I'm going to go farther than you might need to because this is most likely going to be a multiple choice question. And that answer will not be on there. I guarantee you it won't be on a multiple choice because it's not fully, because it's got a fraction over fraction. Okay, so at least we want to fix that. So I got to combine these two fractions by subtraction. So I need to give this guy a denominator. So what's the common denominator between those two fractions on the top of the big fraction? Thought I heard somewhere. What's the common denominator between those two guys? Yep, 1y. Okay. 4y squared. So the bottom's going to be just y. The top will be 4y minus 2x plus 2 squared. Okay. Still have a fraction on top of a fraction, but at least it's one term over one term. So now what I can do is multiply by the reciprocal of the second or keep, change, flip. So what I can do here is I have 4y minus 2x plus 2 squared over y divided by 4y squared, right? Divided by 4y squared. Multiply by the reciprocal of the second, or keep, change, flip. Keep, change, flip. So you get 4y minus 2x plus 2 squared. And on the bottom, you get 4y squared times y, which is 4y cubed. Okay. There's no need to multiply the 2x plus 2 out. You don't need to multiply that out because there's no other x's. Everything else is y's. So you can't combine it with anything. So this part right here? By doing which part? Simplify how? How would I? Oh, okay. What? Because so there will be a 4. So if I this one doesn't have a 4. Oh, okay, I see what you're saying. I would have to I would have to multiply it out. Like I would have to do that. I would have to take this guy over here and go 2x plus 2, 2x plus 2. So it would be 4x squared plus 4x plus 4x plus 4. So it would be 4x squared plus 8x plus 4. Right? And then I would.
Oh no, just like in general, because you didn't do that in the with the first derivative
Let's see.
either.
Oh, right here. Pull out it.
I'm just asking why.
I just because if that was my finished answer, I would have done that. I probably should have done that. But so talking about like this.
Yeah.
Yeah, no. If that was my finished answer, if I was only finding the first derivative, I definitely would have done that. But I knew I wasn't done with it, and I ended up doing that later, right here. Where is it? Right here. Those twos eventually got canceled out here and here. So yeah, no, I should have done that earlier. Yeah, you're right. Yeah. Yes. Yes. Yep, you're right. You are right. I forgot about that. So it changes that. Yep, for sure. Yeah, no, for sure that would change. Yeah, when I did the common denominator, I multiplied the bottom by y, but I didn't multiply the top by y. So that should have been a 4y squared. Yeah, no, for sure. Yeah, that's definitely important. Thank you. Yeah, sometimes I go too fast on these things. If I go too fast, thanks. Please let me know. Please correct me. Okay. Yes. Huh? Yep. Oh, because I just multiplied. 4 squared is 2 squared is 4, and then y squared is y squared. So I just took away the parentheses. It's the same thing. I just simplified it a little bit. Yeah. Okay. Okay. So let's try another one. Let's try another one like that. The steps aren't hard. It's just when you get into it and simplifying it and everything, that's where it kind of gets a little bit not difficult, just Flores. Hey. Yeah. On the certificate, I did. I thought I did. I sent it to you. Yeah, yeah. It was a Word doc that I sent. You want me to send the PDF? I could just send you a PDF. Okay. Okay. No problem. Bye. Okay. So try this one. If you haven't already, do this one. Okay, so the first derivative, I got x squared over y. And then find the second derivative from there. Okay, so if you're still working, keep working. I just want to catch up to where you guys are. So the first derivative, I got x squared. So this one I'm going to simplify. Yeah, that's probably a good idea to simplify as far as you can because you're going to have to use it later on and it's easier to use a simplified version. So this guy here, quotient rule. Okay, so we got d squared y over dx squared. Okay, so we're going to have y squared on the bottom. Low times the derivative of the high minus high derivative of the bottom. Okay. I'm going to take away the dy dx, and I'm going to put in what dy dx is. Dy dx is x squared over y. So I'm going to substitute this guy in for this guy here inside the parentheses. Because I can't have a dy dx and a d squared y dx squared. So 2xy minus x squared times, and this is where I'm going to put in this guy here. Okay, over y squared. Okay. Simplify inside the brackets. So I'm going to get x to the fourth up top. So I'm going to get 2xy minus x to the fourth over y squared. So now I have one term inside the brackets, so I can take away the brackets now because I've combined, I've multiplied. Okay. The top, I got to do common denominator. So over here, I have a 1, right? So the common denominator for that guy is going to be y. So I got to multiply times y. So I'm going to have 2xy squared over y minus x to the fourth y. See that? Because I multiplied top and bottom by y. It already had a y. So now it's got two y's, y squared, 2 powers of y. Okay. So now I got a common denominator. Now I can combine the top minus x to the fourth over y, and then on the bottom I have y squared. Okay. Keep, change, flip. So keep the first one the way it is. Change to multiplication. Flip the bottom, so now it's 1 over y squared. You get 2xy squared minus x to the fourth over y to the third power. In the numerator, I see I have x and x. I can factor out an x, but I'm not going to do that because it's not going to cancel out with anything, right? You can, but it's not necessary because I don't have x's on the bottom, right? Here I have an x here and 4 powers there, right? So I can factor out an x, take away that one, take away this to the third, but it's not going to cancel out with anything on the bottom because there are no x's down there. So that's why I'm going to leave it like that. Okay. All right. So I want to give you one more of these types of problems. I want to give you one more types of problems so that we can have some practice. So find somewhere, if you don't, find another sheet of paper in your notebook or something. Let's do one more types of these problems. Just while we're here, we have about 10 minutes. Let me get you another one. Okay, there's the problem right there. So this one's got a point. So what am I going to do with that point? Plug it in at the when? At the end, at the very end. Okay, plug it in at the very, very end. You're not worried about that point until you've done your found your second derivative, okay? Okay, so my first derivative is 3x over y. That's the first derivative. Here's the thing about this guy though. The nice thing about plugging in a point, you don't have to go all the way. Like I don't have to like simplify and do all that stuff. Right when you get only x's and y's, plug them in. Plug them in and see what you get. That's the nice thing about plugging in points. It's actually not more work, it's actually less work because you don't have to actually solve it all the way for dy dx. Like I would have to like here, I would have to keep going with a common denominator and everything like that, right? I don't have to do that when I have points to plug in because I know my x and y are right here. So anywhere I see an x, I plug in a -2. Anywhere I see a y, I plug in a -3. Simplify, get an answer, and that's it. You're done. Okay, so x is -2, y is -3. So I get -9 minus 36 over -3 over 9. Because -2 squared is 4 times 9 is 36, and then over a -3 on the bottom. Well, double negatives here minus a negative, that's going to be a positive. And -9, 36 over 3 is 12, plus 12 over 9. 3 over 9, which makes 1/3. Okay. So by plugging in a point, it's actually less work because you don't have to simplify everything down. Once you get to a point where you're just what you've plugged in, once you've plugged in here and you simplify it a little bit and you only have x and y's, then plug in your point there and you're done. Okay. Okay. So I'm going to, there's going to be an assignment in Google Classroom. Okay. It won't be due till Friday. Okay. By the end of the day. All right. See, is there anything else? I think that's it. All right. Let me upload these notes.